Have you ever wondered why the old light bulbs get hot and the new LED light bulbs don't? This tale begins over a century ago with the invention of the incandescent bulb. A marvel of its time, these bulbs lit up homes and streets, changing the way we live. But beneath the glow lay a significant flaw: inefficiency. My name is Anton Dobrovsky, I'm a passive house consultant and for the past 9 years specialized in designing energy efficient buildings. And in this video we will delve into the fascinating journey of the light bulb, which is an everyday object whose evolution holds key insights for how we can make more sustainable buildings. But firstly, imagine this. About 90% of the energy used by these bulbs was not producing visible light at all. Instead, it was emitted as infrared light, a spectrum invisible to our eyes, and this infrared light was perceived as heat, making these bulbs hot to the touch and incredibly wasteful in terms of energy use. Think of it, most of the electricity powering this bulb was used to generate heat, not light. That's why these lamps are still used as heating lamps, for example to keep food warm, used to provide heat to smaller animals, but when we speak about humans, well, the goal is to provide light, not heat. And then came a revolution in lighting technology, the LED or light emitting diode. LEDs transform the way we think about light bulbs. Unlike their predecessors, LEDs are designed to convert almost all their energy into visible light with minimal heat emission. And this shift wasn't just about better light bulbs, it was a leap in efficiency and resource utilization. This efficiency is achieved through precise control over the light spectrum. LEDs take most of the energy you need and want in a light bulb and put it in the visible part of the spectrum. The results are striking. An old 60 watt incandescent bulb might produce the same amount of light as 9 watt LED, making LEDs almost 10 times more efficient. So what started as a simple quest to illuminate our nights has turned into a lesson in efficiency and innovation. The story of the light bulb is more than just a history lesson. It's a blueprint of how we can rethink resources and design in other fields, particularly in architecture. The evolution of light bulbs, this fundamental shift from wastefulness to efficiency, from heat to light, is a proof for the adaptability of technology. Just as light bulbs evolved from incandescent to LED, our approach to architecture must also evolve, and now we will explore what architects can learn from this evolution. It's not just about using new materials or techniques, it's about a fundamental shift in mindset. Architects are tasked with designing not just for today, but for a future where resource efficiency is crucial. One key lesson from LED technology is the efficient use of resources. LEDs maximize the output while minimizing waste, a principle that can directly translate to sustainable architecture. For instance, how can buildings be designed to minimize the energy consumption? Well, a study by the International Energy Agency from 2020 shows that 56% of the energy used in buildings is used for space heating and cooling. So the right question to ask is, how can we minimize the energy for space heating and cooling, right? Well, we can do it by keeping as much of the heat inside the building, and that's exactly what the passive house standard focuses on. Similarly to LEDs, which are 90% more efficient than their predecessors, passive house buildings use 90% less energy for heating and cooling compared to standard buildings. And the future we foresee is one where buildings do more than just minimizing energy consumption. They actively contribute to energy creation and sustainability. Imagine structures that are not only energy efficient but also energy generating. Similarly to how LEDs revolutionized lighting by producing more light with less energy. And this could be achieved through integrated solar panels, wind turbines, and other renewable energy technologies. Additionally, the integration of smart technology in buildings, inspired by the smart capabilities of modern lighting systems, can lead to more efficient energy use. Buildings could automatically adjust lighting, heating, and cooling based on occupancy and weather conditions, much like how LEDs provide optimal lighting with minimal energy waste. And efficient resource use in architecture also extends to spatial design. Just like LEDs optimize light output, buildings can be designed to optimize space, reducing the overall footprint and material usage without compromising functionality and comfort. And this includes intelligent layouts that maximize utility of each area and multi-purpose spaces that adapt to different needs. Another lesson is the importance of targeting the right spectrum, metaphorically speaking. In lighting, LEDs focus on the visible spectrum, the most useful for us. In architecture, this translates to focusing on the well-being of occupants, to create buildings that enhance the living and working environment. And this involves maximizing natural light, ensuring good air quality, and using materials that are not only sustainable, but also healthy for the occupants. Furthermore, the LED revolution teaches us about longevity and reduced maintenance. LEDs last significantly longer than traditional bulbs, which means fewer replacements and less waste. In building terms, this translates to designing structures that are more durable, needing less maintenance, but also flexible enough to adapt to future needs, reducing the need for extensive renovations or replacements. We also see a future where the principles of circular economy are embedded in building design. This means using materials that are recyclable and biodegradable and designing buildings in a way that their components can be easily repurposed or recycled, mirroring the longevity and reduced waste of LED technology. Lastly, there is a lesson in the democratization of technology. LEDs have become widely accessible, transforming lighting in homes and businesses around the world. Similarly, sustainable architecture shouldn't be more expensive and a privilege of the few. It should be an accessible goal for all types of buildings, from small homes to large commercial complexes. And the best thing is, we already have great examples for such buildings. In 2019, this social housing project consisting of 93 certified passive house homes, the Goldsmith Street project, has won the Sterling Prize. That's a prize awarded to the UK's best new building by the Royal Institute of British Architects. And the residents, well, they pay low energy bills and live in comfortable and healthy environments, while, and you probably guessed it, using LEDs for lighting. And although LED bulbs and passive house buildings represent significant advances in energy efficiency, they still consume some energy. And the goal of a lot of countries is for this energy to come from renewable resources. Therefore, we are currently transitioning from fossil fuels to renewable energy sources. And in this crucial phase, architects and engineers hold a vital role, because without them, this will be an impossible challenge. So to learn how architects are not just building designers, but key players in shaping a sustainable, energy-efficient world, make sure to watch this video.